and then start sharing. So if you have any doubt on whatever we have discussed so far, so you can ask. So anything you have?
স্যার লাস্ট টাইম বলেছিলাম যে একটা ওই ল্যাব ওয়াইন্ডিং এর একটা টোটাল ডায়াগ্রাম যদি আপনি দেখিয়ে দিতে পারতেন যে 15 স্লটস এই 15 এর যে আপনি করেছেন
Lab or web?
ও সরি ওয়েব ওয়াইন্ডিং
Okay, so I think many of you have already submitted the wave binding, and I can open one of your copy, and then I can discuss that. So let me open one of the copy. Just a minute. Okay. So can you see this? Can you see this?
ইয়েস স্যার
Okay, so this is the copy by Sharnodeep Shaha, your friend. He has done this, and first he has calculated all these parameter which will be required for the winding, and I think you have understood this part. Uh, First we have started with winding pitch, commutator pitch, back pitch, and then front pitch. Accordingly, uh, he has made the table, winding table, and that we have already discussed in the class. So here you have the back pitch, then front pitch, then back pitch, then front pitch, like this. We have made the table, and then first, as I told you, he has drawn the uh, winding diagram in radial form, and it's a generator. And yes, I think, okay, so he has shown that the generator operation in counterclockwise direction, and accordingly he has shown the current directions under different poles. Like under north pole, he has placed all the dot, and under south pole he has placed all the cross, as per the operation type of operation, that is generator, and direction of rotation, that is counterclockwise. So first you have to uh, place the marking dot and cross on the conductors, and these are all double layer winding, so there are two layers, two conductors in each slot. Now under the north pole dot, and under the south pole cross. So this is how he has made this. Then what he has done, he has shown all the coils as per the winding table already made. So he has uh, drawn the coils, like one coil is starting from uh, commutator segment 1 and passing through the coil side number 1, and this returning back from this 10. Okay, so you can just check it whether it is correct or not. You just see the first one. So 1 to 10, then 17 to 26. So you see, so for the first coil is passing from 1, the top coil sides of one slot, and it is returning back to the bottom coil sides of another slot, and that is coil side number 10. Okay, and then the next coil starts from the same, which is connected in series with the same coil, and that starts from this coil side number 17, and return back to which coil side is it? Okay, so it's 26, I think. So 26. So you just check whether he has done the correct thing or not. 17 to 26. So you see, it's 17 to 26. So this is how. He has made all the coils and also shown the current direction like this. Okay, so as for the dot or cross, he has drawn the current direction. Now, the second, the last thing you have to do here, that is the placement of the brush. So as you know, in case of wave winding, irrespective of the number of holes, there will be only two parallel paths and two brushes will be placed. Now, where to place the brush? Now, you know, as I discussed in case of lap winding, the brushes should be placed uh, placed at a location or at the location of the commutator where all the currents are either entering or outgoing. So here, so like this, he has placed one brush at 4, because you see at 4, this commutator segment 4, two coil sides are connected and two coil sides are carrying the outgoing current. So he has perfectly placed the brush at the commutator segment 4, no question in that. Now we have to search, because all these currents are outgoing. Now we have to search another position of the brush where both the currents are incoming. So if you see uh, where the both the currents are incoming, you see that that type of coil, where is that, where you just check it, where we're getting that both the coils are incoming. Is it at
Sir,
15?
coil 29 and 8.
Okay, so
Actually,
coil 29 and 8, correct. So you see the coil side number
yes, sir.
29 and the coil side number 8 here. That means it should be. Uh, can you see my the pointer? So it should be placed somewhere here, isn't it? Can you see my pointer?
Yes.
Yes, sir.
Okay, so you see there is some marking I have made. So it should be placed on this, because you have both the currents are incoming at that node. But as it is not connected with the commutator segment, so you cannot place the brush over there, because it comes in the overhang portion of the coil. So you cannot place the brush over there. Then what you have to do, either you have to connect the brush at 15, or you have to you see the coil side number 29 is also connected with 15 commutator segment number 15, and another coil side which is connected to the same point, that is coil side number 8, is connected to 8. Okay, so either you can place the brush at 15 or at 8. So he has placed the brush at position commutator segment 15. So if you place the brush at 8, that also will be correct. So he has also done another form of this, you see. So another form by which we can show the winding of a DC machine is like this. So this position is okay, but you see this position, so that means it's 29 and 8. So 29 and 8 should be at the upper location, but the brush cannot be placed on that location. So therefore it is connected with the other side of the 29. Okay, it can be connected either one side of the 29 or another side of the coil side, the coil side 8. So yes, connected with other side of the coil side 29. Okay, so this is how, so two parallel paths are made. You see, this is how two parallel paths are made between two brushes. So current, whatever the current armature current will be flowing, that will be halved in two paths. So if you have any doubt, you can ask. Jahat, anything?
Okay, sir.
Anybody has any doubt? Because you have to understand this thing clearly. You just check it yourself whether you have understood it or not. Today the attendance is very poor. I don't know why. Okay, so let me stop this share because that we have already discussed, and let me start the class with the commutation process. So we have already discussed how the currents are in a particular coil gets reversed, and that is called the commutation. So I think this we discussed in the last class. So if at any instant some coil there is IC current, after commutation it will carry a minus IC current, and this process of reversal of the current direction is called the commutation. Now this change of coil current, that is IC, can be linear, as I have shown by this red line. Okay, so it can be linear. So it can be any type, as I shown by the blue lines. Okay, so like this, like this, like this. So it can be any type, any kind. Okay, so depending on the change of this coil current from IC to plus IC to minus IC, there are different types of commutation. So I will discuss all this today. Okay. Now, first I will discuss the resistance commutation, where I will neglect all the inductances. Only I will consider the resistances. So resistance, there are different resistances. Resistances will be there in coil. Resistances will be there between the brushes and the comparator segment. Okay, so let me go to the first drawing. That means the drawing number 1. Okay, so here you see. So if I define the resistances, like the resistances of coil, resistance of coil. So that, suppose that is the RC, and some resistance of the. So here I have taken 2 and 3. So that means first the resistance between the brush and the commutator segment 2. So let me define the resistance between the bar 2 and brush. Okay, so that let me define with R2, and after some time you will see that the brush will also come in contact with the commutator segment 3. So for that, let me define another resistance. So resistance between, okay, so bar 3 and brush, that is R3. So these are the three resistances. Okay, so is it okay? Now, I'll write some equation. The equation which we'll get from this Kirchhoff's voltage law, KVL. Very easy. So can you write that, the Kirchhoff voltage law equation for this particular coil?
Yes, sir.
So you just try to write this.
So which one?
Which one means? For this position one. For position one. Okay. Because position one, other current you don't know. Okay, so for position two, you try to write. For position two, you try to write the KVL. Sorry, KVL for position two. Because here you can draw some loop. So for this particular loop, you try to write the KVL equation for the given direction. All you try to write, I will ask you. What is this current? What is this current? Can anyone tell me?
2IC minus I dash.
So as
2IC
per
minus I
IC
dash.
minus
correct.
I prime.
So because IC minus I dash and IC from the right, so that means 2 IC minus I dash. So these are the three current in this loop. So accordingly, you just try to write the equation. Okay, so coils through the coil, how much current is flowing? So IC minus I dash, and you know the resistance is RC, and it is in the direction of current, so it is minus. Then then the drop between this 2 and brush, and what is that current is 2 IC minus I dash, and that is into R2, and it is in the opposite direction, so it is plus I prime. So this is prime also. So this is also I prime into R3. So this total sum equals to 0. Sorry, so I was out of the class due to the poor connectivity. So am I audible now?
Yes, sir.
So I don't know where up to what you have. Uh, so have you seen this
So you are
KVL?
writing the equation.
Huh? The KVL equation, have you seen this particular
So you
equation?
have not shared.
So I have not shared, but it is in the sharing mode only.
Sir,
Okay.
you have not presented yet.
You have not shared.
Now it is okay. Is it okay now? Can you see the board?
No,
No,
sir.
No,
sir.
sir. No, sir.
No, sir.
Why? I'm just sharing. Now?
No, sir.
I don't know. So I'm
So
sharing it,
you,
showing that
you have entered without a microphone.
without microphone.
Yeah, yeah, here is showing that.
Without
No,
microphone,
sir, you are audible.
okay. So what is the problem? I'm sharing
Now
also.
it's okay, sir.
Can you see the board now?
Sharing is
What it is showing?
Yes, sir. Now it is showing that yes, sir.
showing.
Now
Yes,
the
sir,
Now
board
now
is
it is
okay,
okay.
sir.
Okay. So that means, so this is the KVL equation. You just check it whether I am right writing this KVL equation or not. You just check it. For this particular loop, which is going under commutation, for that I have written the KVL equation. Just check it. For position number 2, I have written the KVL equation for the coil which is going under commutation. Okay. Now from this you try to find out the value of I prime, because that is the variable here. You find out the variable I prime. So all you just try, you just tell me what is the value of I prime from this KVL.
so two.
Follow?
Sir, 2 ICR2 plus ICRC divided by RC plus
Two,
R2 plus R3.
slowly. 2 IC
R2
2 ICR2 plus
plus ICRC.
ICRC, okay,
Yes.
divided by
Then whole divided by RC
RC
plus R2 plus R3
R2 plus R3,
plus R2 plus R3.
okay. Now this also you can write like this. You can take IC common, and this 2 R2 plus RC divided by, sorry, this is small, so RC plus R2 plus R3. Okay, so this is general equation which I have written for this position 2.
Sir, your audio is not coming clearly.
Not audible.
Not audible at all, or the voice is breaking.
Now it is okay, sir. Now it is okay.
Okay,
Now it is okay, sir. Previously it was breaking.
okay. So I think you have understood this expression of IC. Now what is the current through the coil? Because the main variable is that. What is the current through the coil? Current through the coil
IC minus I
is
dash.
IC minus I dash. So the current through the
IC
coil,
minus I dash.
correct. So current through the coil, IC minus I dash. So what is that? The same IC minus 2 R2 plus RC divided by RC plus R2 plus R3. Okay. Okay, one more IC was there, right? This IC. Now if I take the IC common, so it will be IC minus I prime equals to IC 1 minus 2R2 plus RC divided by RC plus R2 plus R3. Okay. Now if I simplify it, so what will be there? So RC will cancel out, I think. So it will be
IC into R3 minus R2 divided by RC plus R2 plus R3.
okay, R3 minus R2 divided by the same thing, isn't it?
Yes, sir.
Okay, that is fine. Now, so this is the expression we have obtained. So is it correct? Okay. Now what we can write? We can write by adding this like this. This expression we can write R3 plus R2 because already we have R3 plus R2 in the denominator. So minus R2 so that we can divide that. So this we can write. The minus R2 we can write plus R2 minus 2R2. So if we can write this and then if we divide by R2 plus R3, so it will be 1 minus 2R2 divided by R2 plus R3. So this is 1
ক্লাস
plus
হচ্ছে এখন
okay. So 1 minus 2R2 by R2 plus R3 divided by 1 plus RC by R2 plus R3. Now here I will make one assumption. Okay, so what kind of assumption I can make here? Now you see the resistance. There are two types of resistance. One is the pure copper resistance. Another is the resistance between the copper segment and a semiconductor type material, that is carbon. Now can you tell me which resistance would be in higher side? The carbon resistance or copper carbon contact resistance? Any idea?
Carbon resistance.
Not only carbon resistance, this is called the contact resistance. Okay, so the contact resistances here are R2 and R3.
Okay, sir.
So you can say that this R2 or R3 is greater than this RC value. Okay, now if that is the case, then for the time being we can neglect the value of that means this denominator, this think we can take 0. Can't we make this assumption? Very negligible or 0. Then we have only the numerator, isn't it? So if this is the assumption and if we take like this, then this R2 plus R3 almost negligible, and we can have only the numerator side. Okay. Now, if I can neglect, that is okay. But if we want to exact analysis, then we have to consider the coil resistance also. Remember, this is an approximated study we are going to do here. But if we go for the exact analysis, then it would be, so that also I will discuss. Okay, so this is an approximation where I have neglected the term RC by R2 plus R3. Okay, is that clear? Now you see the resistance R2 and R3, whether these two resistances are constant or variable. And what about this resistance RC? Whether that is constant or that is also variable. Any idea?
Sir, R2, R3 are not constant.
Depends on
Why?
the RPM.
Okay. Any other?
Sir,
Sir,
R2 and
the
R3 are not.
brush
Sir, the area of the contact R2 and R3 means sorry,
inversely
R2 are inversely proportional on the area of contact
Okay, so that means
of the brush with the commutator of the bar and the brush.
so if I draw the commutator like this, and if these are the commutator segment like this, and you have placed your brush like this, so this is your 2 and this is your 3, and you have placed your brush like this. So this is the brush which is connected with some terminal. So this is the brush. Now if we analyze this, so a part of, so if I zoom it and if I try to draw the brush, okay, the brushes like this cuvette. Now this area, so am I audible now? Again, I was out of the class. Am I audible now?
Yes, sir.
Okay, so I was discussing this.
Yes, sir.
Can you see the board?
Yes, sir.
Okay, so these are the area.
Sir, can you start from the previous part? Just
Which one? I was discussing how how the contact resistances are formed. The contact resistances are basically formed between the brush, carbon brush, and the copper surface of the commutator. And when the brass is in contact with multiple commutator segment like this, so here it can be in contact with two commutator segments at a time. So this is how it has formed two resistances, one with commutator segment 2 another with commutator segment 3. So the resistances between the commutator segment 2 and the carbon brass is, we have defined R2, and the resistances between the commutator segment 3 and the brush I have defined by R3. Okay, now this R3 is basically will depend on the this blue shaded area, and R2 will depends on the red shaded area. Okay, and if I take this area is A2 and this area is A3. Now what we can say about this R2? R2 is inversely proportional to A2, isn't it? Or we can write some K by A2. And what we can say about R3? R3 also inversely proportional to A3. Am I audible clearly?
Yes, sir.
Can't we write like this R2 and R3 value? You just take it. Now this we can write 2 into K by A2 divided by K by A2 K by A3. Okay. So this will give me what? It will give me 1 minus A3, or rather 2A3 divided by A2 plus A3. So is it okay? So I'm facing a lot of problem today. I don't know how I can proceed with this. So am I audible now?
Yes, sir.
So have you written these expressions? Connectivity is very poor today. I'm trying with different connections, but all the connections giving me the trouble. So you just write this, uh, then I will proceed. Is it okay?
Yes, sir.
Now let me draw the commutation interval. So the current was initially plus C, and after this interval, which is defined as TC, can you tell me what can be the value of TC? How can I determine the value of TC? Any idea?
Sir, brush width divided by the peripheral velocity of the commutator,
Correct.
actually rotor.
Commutator. The peripheral speed, you can say, because that is the peripheral speed, and that depends on the diameter. So that is the peripheral speed VC and the brush speed BW. So that determines the value of the commutation time TC. Okay. So this is the value of the coil current with respect to time. And I have shown the linear commutation, but let us see what type of commutation we should get. Now, for this approximated study, if the brush is initially the brush the position for the position number 1, the brush was totally in contact with commutator segment 2, and there is no portion overlapping with commutator segment 3, and that time what is the value of this A3? Can you tell me for the position 1, because I have drawn the 5 positions, so I will discuss all for all these 5 position 1, 2, 3, and if you have the node, you just check and tell me that what should be the values of A2 and A3, because here we have expressed the coil current in terms of A2 and A3 only. So for position number 1, what should be the value of A2 and what should be the value of A3? Can anybody tell me that?
Sir, the position, would you please mark the position,
Position I have
which is
already
1, which is 2, which is 3?
no, I have already marked in the previous class, na? If you can, if you have the
A3 will be
notes.
0.
Sir, initially A3 equals to 0.
So
A3
this
will
is
be
the
0.
position number
A3
1 where the brush
is
is
0
totally
initially.
in contact with 2. There is no contact with 3. Okay, so that means we can write A2 has some finite value, but A3 is 0, isn't it? So A2 has some finite value, but A3 is 0. And for position number 2, where the brush has a slight in contact with 3, but the maximum contact with 2. So that is the position number 2. And position number 3 is almost similar contact with 2 and 3, almost same. So that means A2 and A3 will be same. For position number 2,